So the next thing we're going to talk about is a term called stoichiometry. So if you can say this word and write this word, you've made it as a chemist. Okay? Stoichiometry. And so what is stoichiometry? Stoichiometry refers to the numerical relationships between chemical amounts in a reaction. So stoichiometry is going to relate how much I have in my balanced equation in a reaction. So say I had this balanced reaction. So this is the combustion of octane. Okay, so here's my balanced equation. So I have my coefficients, 2, this is 25, not SO2. In case you were trying to figure out, that's a 25. So 2, 25, 16, and 18. So 2 octanes, 25 oxygens, 16 CO2s, and 18 waters. So what stoichiometry is telling me is a mole-to-mole relationship. How can I relate this to that guy? How can I relate all these compounds together? I do that using my coefficients. So what this 2 is telling me is that for every 2 moles of C8H18, I have 25 moles of O2. I can relate a reactant to a reactant, but I can also relate these guys to the product. I can say for every 2 moles of C8H18, there's 16 moles of CO2. I can also relate that to the other one. It's also equal to 18 moles of H2O. So what this is telling me is this balanced equation is giving me a way to go from one thing to something completely different. This is brand new. We haven't done this. We've gone from one thing to something else, but they had to be related. So we talked about how can I go from CO2 to carbon, or vice versa. And remember we did that using the percent composition. So I could go from the whole to the part using the percent composition, or I could say for every 1 CO2 there's 1 carbon, or for every 1 CO2 there's 2 oxygens. So there's what I call an inner mole-to-mole ratio there. So far we've done that. We could go from the part to the whole, but they had to be related. Now we can go from something to something completely different. This has C8H18 all the way to something that has oxygen in it. So now we can go from one thing to something completely different through a mole-to-mole ratio. So the big things you have to remember is it has to be in moles. This relationship does not work unless it is in moles, and that ratio comes from the coefficients in a balanced equation. That's why we had to know how to balance our equations first. Okay? So let's look at an example of how this is going to be helpful. So let's recopy that equation. It's the same one that I had before. Okay. Say I have 22 moles of my octane, and I want to know how many moles of the CO2 I have. So you have moles of octane, and I want to know moles of CO2. So what you should notice is you have one thing, and I want to go to something completely different. The only way you can go from one thing to something completely different, and I keep saying this because this is important, because this is the basis of chemistry. Basis of chemistry is reacting stuff together and making new stuff. So what the rest of this chapter is about is really important. Okay? So if I want to go from one thing to something completely different, it's going to be using that mole-to-mole relationship. It's going to be using stoichiometry. Stoichiometry helps me go from one to another. The only way I could go from one to another is when they're in moles. So these guys are already in moles, so that's helpful. So I start with what I have. I have 22.0 moles of my C8H18. I don't want C8H18, I want to go to CO2. So I want to go from here to here. I can only do that if it's in moles. Since this is already in moles, I don't have to convert it. If this were in grams, I would have to put it in moles first. But since it's in moles, I can go from moles of that guy to moles of whatever I'm trying to go to, and in this case, it's CO2. So I can convert from one to the other. The numbers that go in my parentheses are my coefficients. So how many CO2s? 16 CO2s and 2 octanes. Come from my coefficients. I do the math. 22 times 16 divided by 2 gives me 176 moles of CO2. Okay? So this is stoichiometry. This little parenthesis here is stoichiometry. How do I go from one thing to something completely different using a mole-to-mole relationship and those coefficients? These numbers are my coefficients for my balanced equation. All right? Now let's do another problem. For the next one, we're not going to have moles because in the real world, we don't go in the lab and measure out moles. In the real world, we probably start with grams or kilograms. So let's look at a more realistic real world problem.